Question 8.43 says, use molar volume to calculate each of the following at STP. So standard temperature and pressure I have written here. Temperature is 273 Kelvin and pressure is 1 atmosphere. So we want to calculate the molar volume for each of the following. So the number of moles of oxygen in 44.8 liters of oxygen gas. So for A, we know that at standard temperature and pressure, so at this temperature and this pressure, 1 mole of an ideal gas occupies or takes up 22.414 liters, but we're only given 3 sig figs, so I'll just put 22.4 liters. So that means that our N1 is going to be 1 mole. Our V1 will be 22.4 liters, and we're given, in A, we're given V2, which is equal to 44.88 liters. So hopefully you can see that when we have volume and number of moles, that the law we need to apply is Avogadro's law, which is V1 over N1 is equal to V2 over N2. So that means, N2. So that means that volume and number of moles are directly proportional to each other. So as the number of gas particles increases, the volume increases, which is quite intuitive for most people. So if we just rearrange our formula to solve for the number of moles of oxygen in that 44.8 liters, we'll say that N2 is equal to V2 times N1 over V1, like that. And then I can simply plug the numbers into my equation. So I'll put 44.8 liters times 1 mole, which is an exact number, divided by 22.4 liters. So you can see that liters and liters will cancel out, and I'll get that the number of moles of my oxygen, I'll just put N of O2, is equal to 2.00 moles. And I'm sure that some students can even solve this problem in their head. So let's take a look at part B. And part B says, calculate the volume in liters occupied by 0.42 moles of helium gas. So again, the identity of the gas is unimportant. We know that at standard temperature and pressure, when we're dealing with ideal gases, that 1 mole of a gas is going to take up 22.4 liters. So again, we can apply the same formula. We can still use Avogadro's law. So we're going to use the same law, except this time we're going to solve for V2 because we're looking for the volume in liters. So V2 will be equal to V1 times N2 divided by N1, like that. So I'm just going to put my numbers, substitute my values into the equation. So 22.4 liters multiplied by the 0.420 moles divided by 1 mole, and again that's an exact number. So you can see that moles and moles are going to cancel like this, and my V2 will be 9.41 liters of helium in this case. So for part B I get 9.41 liters of helium. So again, the identity of the gas is unimportant when we're using Avogadro's law. So first of all, you have to know that at STP, 1 mole of gas will occupy 22.4 liters. And you need to know that volume is directly proportional to number of moles, which can be rewritten in the form of Avogadro's law, which is V1 over N1 is equal to V2 over N2. And I think it's a good idea to memorize that law if you're studying gas stoichiometry in chemistry. So I hope you find this problem and solution helpful.